Hello, welcome to Chapter 5. This is probably one of the most important chapters this year. It's on a topic that is central to Algebra 1, so make sure that you're listening because we will be using slope basically, in almost every single chapter after this year. So you definitely want to make sure that you have a good foundation on slope. And slope is really derived from what we call rate of change. So we're going to briefly look at what rate of change is, and hopefully we can tie it into what slope is. Now, what's rate of change? Rate of change is simply the change in the dependent. Now, that was, remember, vocabulary from last chapter. The dependent variable is your y, and it's the change in the independent, which is your x. So hopefully you got a good chance to memorize that vocab, but basically it's the change in y over the change in x. Okay, so what does that exactly mean? Well, it's a little tricky. It might not make sense with this slide, but as we go through, like for example, this one, you're going to see that there's things that are x and y that are in real life for like time and distance. So time we measure in minutes and distance in feet. This looks like somebody's marching. It could be maybe a band or maybe something in the military. We really don't know, but there's some chart of time versus how far somebody marched. So we're going to look at whether the rate of change is constant. And if it is, find the rate of change and explain what it represents. So let's kind of get right to it. I want to go back and say, okay, what is rate of change again? It's simply the change in y over the change in x. As I look at these, they kind of look like x's and y's, and I'm going to treat them that way. I'm going to sneak a little x right here and a little y right here. That helps me kind of understand what I'm doing. So it says that rate of change is the change in y over the change in x. All right. So we're looking to see if it's constant. Now, as I look through the pattern, at 1 minute, we're at 260, 2 minutes, we're at 520, 3, 780, and 4, 1040. So I'm saying, are they marching at the exact same pace each minute? That's what it would mean to be constant. So basically, if something's constant, it makes a graph kind of like this. But let's say, I don't know, they're marching and they were running real quick, and then they slowed down, and then they start speeding up, you'd get something like that. So we're seeing if it's a constant graph or if it's like something that would be kind of sporadic. All right, let's get to it. So how are we going to figure that out? How are we going to see if it's constant? Well, let's look at the change in y. Let's see how y is changing. I'm going to get my calculator out so you can see the actual math happen here. Let's basically take a look from 260 to 520. I want to know the difference. Now, difference is a key word in math. That means subtraction. What's the difference between 260 and 520? So you start with your bigger number, 520 minus 260, and we end up with actually 260. So from here to here, I have a difference of 260. I'll sneak a little 260 right there. Now, what about from here to here? Let's see, from minute 2 to minute 3, how far did they march? 780 minus 520, 260 again. Okay, so far they're marching perfectly. And then let's see from the last one, 1040 minus 780, 260 again. And I want to be clear at what I just did. I subtracted my y's. I took these two, subtracted them. I took these two, subtracted them, and these two and subtracted them. And I found all of my differences to be 260. I'm going to look at my time to make sure that was consistent. I definitely don't need a calculator for that. It looks like all the jumps are by what? By ones. It's like going up by one each time. So every minute, how much farther are they going? That's the question. And we kind of answer that right here. So let's first answer what they want to know. Is it constant? It is constant. And that means, class, once again, if we were to make a graph of this graph right here would look something like this. It would be a straight line with no changes whatsoever because it's, once again, we are progressing at the exact same rate. And that's what that rate of change means. Find the rate of change. We definitely already did that. So our rate of change equals 260 over 1. If you remember, I'm going to kind of flip back real quick. It's the change in y over the change in x. So that's what I did down here. That was our change in y each time, and our change in x was 1. So it's constant. Our rate of change is here. And explain what this rate of change means. And that's where you want to do a sentence, and I'll go ahead and give you that. When you think about it for a quick second, though, every minute goes up. How much farther are we going? So at 0 minutes, we were at 0. At 1 minute, we're at 260. At 2 minutes, 5:20. And once again, they're all jumps by 260. So for every minute, I'll put they marched 260 feet, because that's our units we're in. So for every 1 minute, I guess I'll put the 1 in here, I'll sneak it. I really should have done it. For every 1 minute, they march 260 feet. So every time there's a new minute, I'm going to clean this up a little bit. Every time there's a new minute, we basically marched another 260, which makes it perfectly constant. Our rate of change is right on the money. So for every 1 minute, they march 260 feet. So that's rate of change. And you may be saying, that kind of looks familiar. And it should. There's a lot of things like that are involved in finding the slope. And I'm going to show you those things here in a sec as we get to slope here. So what is slope? Slope, very simply, and make sure this is all notes here. What is slope? Is the measure of steepness of a line. So it's how steep a line is. We have a way to measure that. And this right here, class, is extremely important. This is called slope formula. I can't stress this enough. Make sure you highlight this. Put a box around it. I'm going to go ahead and get my highlighter tool out. I need to make sure I never lose this in my notes. You need to commit this one to memory, folks. So the slope formula. Very, very important stuff here. We will be using this a lot this year. So what does the slope formula do for us? Well, it's pretty simple. It finds the slope. And that right there, M, is actually slope. So we use M in math for slope. So slope equals y2 minus y1 over x2 minus x1. Now, I want to show you what this is not real quick below it. This is not y squared. Don't make sure you understand that. This is y, we say sub 2, that's subscript, minus y subscript 1. Make sure that they're in the lower position. I see that mistake quite a bit. Same thing with the x's. They're in the lower position. They are not exponents, so please don't confuse them. Basically means we've got two y's, and this is how we separate the two y's. We've got, y2 and y1. And also slope, and I'm sure you've heard this a million times in the past, is equal to rise over run, which is the same thing as this right here, actually. And hopefully we'll start to make these connections as we see this lesson progress. All right, this is an important chart. I want to make sure that you have this in your notes. Make a really nice chart for your notes. There's 4 kinds. Positive. We always read slope this way. And you know how that's easy to remember? How do you read words? At least in English. How do we read words? We read from left to right. And you read slope the same way. So what I like to do is think, all right, I'm on my skateboard. Here I go. You do not have to draw this in your notes, folks. I like to do things like this to help you understand. I'm rolling this way. I'm going uphill. That is positive. And if I'm rolling my skateboard this way, which way am I going? I'm going downhill. Now, if I'm on my skateboard here, I'm not moving at all, am I? So that's where we would have zero slope. There's no steepness here. And I have a little thing here. Y values will be the same. These are nice little tricks to add to your notes. And what happens on my skateboard here? This is completely vertical. And it wouldn't be too fun here. So I would drop. I couldn't even stay on this line. It's too steep. We don't even have a definition for this. And I'll talk about what this means in a minute. But basically, your X values will be the same. So this is undefined. You can't even stay on the line. You kind of just fall right down. So positive, negative, 0. This is how we say it. We don't say no slope. We say zero slope. There's zero steepness. This has basically something that we don't have a definition for, too much steepness of some way, but it's a very tricky thing in math to explain. So we're just going to say undefined. All right, read slope like you read the words. Hopefully you take a pause on this screen. Make sure you have this down. I don't mind if you want to draw the skateboard guy as well. And if you really want to, it's up to you. You can pause the video right now and draw Mr. Slope Guy. It helps you remember. That's a positive slope. That's a negative slope. There's an undefined slope. And this is a zero slope. So if you want to draw Mr. Slope Guy, it's optional, but it might help you remember it. Let's keep going with slope. All right, we're going to start off by using rise over run. This is what basically most people start off by learning how to find slope. So this is critical. Once again, this year, a big moment. How do we find slope with rise over run? The first thing we do basically anytime we're in algebra, find 2 points. I can't say it enough. Find 2 points. I'm going to write this down. Find 2 points. we do an exclamation point here? Find 2 points. Find 2 points. Always find 2 points. So get in the habit of immediately seeing a graph and looking for 2 points. Good news, there's a lot of points here. So I'm going to go down the line. I'm just going to peek around. I see a good one here. And I'm going to look. I mean, I see some others. I see one here. I see one here. You literally can grab any one you want, but I'll just take this one. It's the closest that I'm right here. There's one here. It looks like a pattern, actually, as I see right here, 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 here. Okay, so I grabbed 2 points. Now, how do I do rise over run? It's very simple. It's the change in y over the change in x, right? So what we do is y is your up and down. X is your left and right. So we say rise and then run. All right, so now let's take a look here. What's my rise? I always start on my left point just to be consistent. You could start here, I'll be honest, but I always like to be consistent when I teach this stuff. So I'm going to always start on my leftmost point because I read same way, left to right. So let's start on the leftmost point. How do I get to the other point? What are my directions? Now I'm going to have to go up. How many? Put little dots here. Kind of imagine myself in a little tunnel here going up, like I'm getting directions to the next dot. I better stop right here. How many blocks did I go up? 1, 2. So I went, and I'm going to put plus. I went up +2. My rise, I'll put it over here. A little more room here. Rise is +2. Now, what's my run going to be? I have to go from here to the right. How many places? Just basically 1 block. 1 + 1. Now, obviously, up is plus and right is plus. Down, if we have to go down, is negative. Left is also negative if we have to do that. So I just found my slope. Now remember, what's our letter we use for slope? Take a second and think. M. And the way I remember that, by the way, M stands for mountain. Mountains have slopes. That's what I think about. So M equals 2 or 2 over 1. I do not mind either way, but your final answer really is just 2. We don't actually show the over 1. But since we're talking about slope, and these are directions, I like to put it as a fraction. Let's keep moving here, folks. So I'm going to do the same thing just a little faster, not explain every little step. First thing we do, grab 2 points. I'm going to say that over and over. Grab 2 points. I see one right here in the middle of the line. Let's see. I see one right here. Okay, remember, my system is starting the left dot. How do I get to the right dot? First way, I don't go up this time. I have to go down. Now, since I went down, that is a -1 for my rise. So my rise is equal to -1. That's my change in y. Now my change in x, or my run, how many blocks? 1, 2, 3 blocks I have to travel to the right. To the right is a +3. So my rise is -1. My run is +3. And that makes my slope, this is another rule maybe from we learned in the past, if there's a negative divided by a positive, your answer will be negative. 1/3. So my slope, the negative comes out in front for my final answer. I circle my final answer as well. Few other things to hopefully pay attention to here. You should know the answer is negative before you start the question. If you go back, look at Mr. Slope Guy, look at the chart here, negative slopes go this way. So as I look at my lines, I'm trying to find, I should already know, this is a downhill slope. We always read slope going this way. So if I was going this way, I'd be going down the hill. So once again, you should know it's negative before you even start. But you can see right here, this is why, this is what's happening. Just like this one, I'm going to erase everything, was positive. So I look at it, I look at my slope going this way, and I'm coming up the hill. And it's a pretty steep slope. So also, remember, slope is steepness. If you look back at these lines, if I get rid of all the work, this was a slope of 2, m equals 2. This was a slope of -1/3. And look, it's not that steep. It's downhill, there's your negative, but it's not that steep. That's why it's a fraction. So remember, slope measures how steep a line is. These are just some big ideas we want to keep in mind. All right, we got a special case here. You could do the rise over run thing, and I think I will because it does say to use rise over run. So I got to grab 2 points. I grab this one and I grab this one. How much do I move up and down? What's my rise? My rise is 0. I don't go up or down at all. I can't because I need to go simply just to the right one, we'll say. So I'll just say +1, for example, for my run. And what is 0 divided by 1? 0. M equals 0. Just like the chart said, this is flat. There's no steepness. And if 0 is on top of a fraction, it's always a 0. It's okay in math. But then we have this case. Let's do our rise over run thing just to illustrate what's happening. What's my rise? My rise will be +1 or -1. It really doesn't matter. Depends on which one you start on. But if I was to go up 1, we'll say +1. My run, I'm not going to go left or right at all, is my 0. And this is a problem. You cannot divide by 0 in math. So that is why my slope is undefined. You do not have to show me any work on these special cases, folks. I just want to show you what's really happening in the background. But once again, if you see a vertical line, we basically say undefined for slope. There is no definition. We cannot divide by 0. Okay, now that's how you determine slope looking at a graph using rise over run. But what about if we don't see a graph? Sure, you could draw a graph and plot these points, but it's much faster to use the formula. Now I'm going to say this is extremely important. Again, please listen up. We have a 3-step system. This works for so much of your math and science. I've been using this for years. It really works if you stick with the program. The first step in my system is this: write the formula. Hopefully you remember what formula you're going to have to use for this. I'm going to go backwards real quick here and take a quick look. Right there, slope formula, and there it is. So the first thing I do to find the slope ever when I'm looking at coordinates like this is I write the formula. M equals y2 minus y1 over x2 minus x1. So step 1, write the formula. This applies once again to most math stuff and science. Step 2, plug in what you know. Do I know my y2 or my y1 or my x2 or my x1? Not yet. I have to label some things. So what I need to do is pick 2 points out. And here's the cool part. If this makes a nice line, it doesn't matter which 2 points you pick. I will just basically take the first 2, I guess, and I'm going to go ahead and label these. Now, a lot of students get this wrong with labeling, so I'm going to take a second here to show you how to label properly. I'm going to put the points down here. So -4, -1. Now this is x1. This is not x2. A lot of students do that. This is x1 and this is y1. Here's what it means. This is always the x, the first number, and the y is always the second, just like you're used to. This is simply the first set. That's what the ones mean. The second set, we're going to do -2, comma 2. That's your x2, y2, subscript. So I labeled my points. So now I've got all the ingredients I need. And another rule Mr. Cunningham has, very important for me. Step 1, write formula. Step 2, plug in what you know. When you plug in ever, you always use parentheses. It's the right way to do it. It's the proper way to do it. So before I even begin these, watch how I set this up. I have my students do this every single year, and it works very, very well. Don't fight me on it. Just do it, please. This is the right way. It protects your signs. It protects a lot of errors. I've seen it many, many times help students that were getting silly little things wrong. So please, it takes 1 second. Set the blank parentheses up. Y2 goes here. Y1 goes here, as you can see. So let's start with Y2. Y2 is right here. It's my +2. Y1 is my -1. And you can see right here, this is where things get tricky when you don't use parentheses. Your signs start getting confused. Make sure you're using them. My x2 is on the bottom, so I put my x2, -2. My x1 is -4. And I simply am going to go across the top, and that is actually a +3. Go across the bottom, and that will be a +2. So I am finished. So write the formula, plug in what you know, and then I basically say, so for step 3, it's solve, which was really not much to solve here. M equals 3/2. Slope equals 3/2. I'll take a second. I'm going to reiterate. To find the slope, we will use slope formula, which is, once again, you need to lock that in your brain. And we label our points when we first start this stuff. As you get better, we won't be doing this as much, but we have to do it in the beginning. So we label our points. We put them in the right slots with parentheses, subtract across the top, across the bottom. You can use a calculator for all this, folks, if you need any help. All right, so this is basically the same types of problems here. I'm actually going to skip through these just for the sake of time in your notes. But basically, you're going to do the same thing. I'm just going to start you off. You're going to put x1, y1, x2, y2. because remember, first set of x and y's, second set of x and y's, and you're going to use these. And I might as well just keep going here because I've gone this far. So I'm going to plug in my 15, my 9, my 7, and my 4. And you can take your time on that. I obviously have a lot of experience with this stuff. So my top is 6, and my bottom is 3, and that simplifies to simply a 2. But since we're talking about slope, I like to use over 1. So my answer, circle the equal sign, means you reduced in my class. I have all these little symbols to help me understand my work. So label your stuff. Write your formula, plug in all the pieces properly, nice and slow, look at your formula, and then solve the thing. So same concept here, x1, y1, x2, y2. Please pause the video because I know I'm going fast on these if you need to. And notice how I don't even look at the problem, I just set that up immediately. So there's my setup every time for slope. 1 minus 4, 10 minus 4. You'll get really fast at this, which is what I want. Negative 3 on the top, 6 on the bottom. So this time it's going to reduce to a, I'm going to run out of room here, negative 1/2. I reduce, so I circle my equal sign. So check your work against mine. All right, now, special cases coming here. I can see it already. Now, I'm just going to tell you right now, I've got these 7s here. I already see this, and I put it in the chart, but to see what it looks like, I'm going to quickly show you. I'm just going to plug the stuff right in. I'm not even labeling because I kind of already know what's going to happen. It's basically going to be a 7 minus 7 and a 10 minus a 2, and you're going to get a 0 on the top. And that's why, is this okay is the question. The answer is yes, that's okay. Get an 8 on the bottom. So when 0's on the top, what's your final answer? Slope is 0. But what about when our x's are the same like this? Well, let's take a quick look. So we end up with 20 minus 15, negative 4 minus negative 4. All right. So 20 minus 15 is simply 5, and then negative 4 minus negative 4 is a 0. Is 0 okay on the bottom? The answer is no. So what's our final answer for something like this? This class is a vertical line. So our answer is undefined. You cannot have a 0 on the bottom. Your calculator will tell you something. Error, math error in some way, because you cannot divide by a 0. But if you look up here, 0 is okay at the top. I wanted to show you those real quick just so you understand if you run into those situations, what it is. So now you've seen these two with the graphs. Oh, also, I forgot, I kind of breezed by. So we're supposed to describe this line. So this line, if it's a slope of 0, is a horizontal line. My apologies for skipping over that. And this would be a vertical line. I will go back briefly because I do know the other one said the same thing. I just didn't want to spend too much time on these slides. This is simply a positive line, and you could say it's slightly steep or something, and this is simply a negative line, so it's going to go downwards. If you want to describe the line, it goes downwards, something like this. This one obviously goes up. All right, so our last one, and this is definitely the most challenging. I saved the toughest one for the end. But I'm going to say this, if you've been listening, and I've been going through a lot of new information, but I've got a system for basically almost every type of math problem, science problem that has to do with the formula. This is how you solve it. You basically start with, okay, what formula do I need? The answer is we need the slope formula. So we start off with writing the formula. M equals y2 minus y1, x2 minus x1 in class. If you write this like I'm asking, it takes a few seconds, you will memorize it. That's the idea. It's one of the ideas. But I also like to write the formula because then I can see what I'm plugging in right next to the formula. So here we go. What have they given us? So step 1, write the formula. Step 2, plug in what we know. Well, that's what we're looking. What did they give us? This is x1. This is y1. This is x2 now. We don't know x2. They leave it as x. And this will be y2. But hold on a second. They gave us something else here. They gave us actually the m. So I always label my stuff, what I have, and I also have the puzzle right here. Now it's a matter of putting in the pieces, and properly, please. That means parentheses. Negative 2 is going to go in this slot, so negative 2. Don't worry, you can get rid of the parentheses, usually in the next step. I'm going to set this up like I always tell you to do. Okay, my y2 will be my 9. My y1 will be my 7. My x2 is simply going to be an x. So I'm just going to put an x in there, and then my 1 will go here. Okay, step 1, write formula. Step 2, plug in what we know. And step 3 is to solve. So now we got to like kind of, look at this thing a little better and actually get x by itself. A little tricky when you're looking at this, but it's not so bad. So the first thing I'm going to do is these parentheses really truly are doing nothing. So I'm going to go ahead and drop the parentheses there. There's nothing going on. I'm going to simplify the top. I see a 9 minus a 7. I can easily solve that. That's 2. And I actually don't need, parentheses here either. So I'm going to drop those. So we're left with this. Now, there's a few ways you could approach this, but I'm going to probably show you one of the easiest things you can do in this situation. You can simply cross multiply, and that means you make this a fraction. So I'll put this over 1. So I'm going to go ahead and multiply 2 times this quantity. Now, this is a tricky thing, so take your time here. You're multiplying one term by 2 terms. That means, very important in math, you need to distribute. Let me show you what it looks like. -2 times x minus 1. It looks like this. Equals, this is simply 2 times 1, which is 2. So when you get a setup like this, it's probably easiest to simply cross multiply. Now, some of you might be saying, I could solve this in my head by plugging in stuff for x. That is not at all what I want you to do. That doesn't help you when the numbers get more difficult. The way I'm showing you, you can solve anything if you use these steps. So I will repeat it. Set up a proportion, which means you have to sometimes turn this into a fraction if it's not one already, and then cross multiply. So here we go. Circle the term just like I taught you when we were doing equations. -2x. Now this is -2 times -1 makes it a +2. A lot of 2's going on here, get a little tricky. All right, so let me keep going here. Simply getting x by itself. We get rid of this 2 by subtraction on each side. Goodbye, goodbye. -2x equals, that's a 0 now. And what do we do to detach the -2? Just the -2 we want to get rid of, not the x. Divide by -2 on each side. That makes a +1. That's why we do the vertical slash. X equals, now the zeros on the top, is that okay? Yes, it is. Check with your calculators. You are totally allowed to use those. So our answer is 0. Now I want to go back up to right here in this step and see if this makes any sense. We are claiming that x equals 0. So let me use my eraser, erase the x for a second. Let me go ahead and change colors to blue here. I'm going to plug my 0 in and see if this makes sense, if we got the answer right. 9 minus 7 is still 2. 0 minus 1 is -1. 2 divided by -1 is, guess what? -2, which, well, I'm not going to circle. That's not the answer. That's the check, if you will, which it's supposed to be -2. So we did it properly. Your answer here, the x value, was 0. So this is definitely one of those tricky problems, class. I wanted to show you the steps. I'm going to have you try one of these on your own. So make sure you refer to this. You simply stick with my system. Now, step 1, write the formula. Step 2, plug in what you know, but that does require you label. Label these things. You could do this the first step if you'd like. Label immediately if you want. Write that formula. Put in all the puzzle pieces. Then you'll have a missing piece, and I showed you how to solve for it. You're going to set up a proportion. And one last thing, when you multiply in a proportion, because this happens a lot in these types of problems, when you do a single term by 2 terms, you have to distribute. I see that mistake a lot. Students forget to distribute there. All right, hopefully this was a good, productive lesson. They're going to definitely take a while to take these notes, so you're going to have a few days. Make sure you take good notes. Copy those charts and those examples. Use your parentheses and use that slope formula. Memorize it.